This is Calc 2, Math 1172, and I'm glad to meet you all. My name is Professor Stecker, that's how you say my last name, and I'm glad to be here. I thought maybe we could start off by just looking over the syllabus, and then we'll, get down to some business here. So you can see my, the first thing, I don't know if you noticed, this is weird, but on Wednesdays we meet in a different room and at a different time. So on Tuesday and Friday it's at 9:30, on Wednesday it's at 9 o'clock in Nursing 410, which is far away from here. So I don't know why they did that. Actually, both I'm teaching two classes this semester where they have a different room on Wednesday. I don't know what the deal is, but yeah, that's that. I think that room is a little nicer, but sorry for the confusion. You can see on here my email address there. That's the easiest way that you can get in touch with me, and I am going to be emailing you all from time to time. So I hope that you use your Fairfield University email address. If you don't check that one, you should check that one. I put my office phone number on there. Nobody ever calls me, and you probably shouldn't, but if you want to, that'd be great. My office is Banno GR17. That's on the ground level. That's like below floor 1 in this building. It's a little hard to find, but I'm sure you can handle it. My office hours are listed there. Tuesday, Friday, 11 to 12:30, and Wednesday, 10 to 1. So those are times when I will always be there, just sort of sitting around waiting for you to come and talk about things. If those times are not good for you for whatever reason, we can set up something else. This includes every day right after class for a couple hours, so I hope that that's helpful and a good time for all of you. You can come to my office if you want, or we can always do by Zoom. Like when I'm sitting there in my office, I will have my Zoom thing turned on, and if you want to come that way instead, that's totally fine too. Sometimes I forget to turn it on, but I get an email notification if somebody comes and I'm not there. So if you come and I'm not there, then just wait a moment and I'll probably show up. All right. You can see this QR code there is for the class website. So I don't really like to use Blackboard because I don't like how it's sort of locked down. Hit this thing. This is where you will find, in particular, our homework assignments. So each week I'm going to assign homework assignments from the textbook, and this is where you can find them. You won't see them in Blackboard. If you go to our Blackboard page, all you'll see is a link to this same page. So you will want to visit that at least every week to get the homework assignments. All right, our textbook, I meant to bring it with me so that I could show it to everybody, but I think you probably all have it already. It's the Stewart book. This is the same one that you used if you took Calc 1 here last semester. Is that true? Do you mind if I ask, did you all take Calc 1 here last semester? Anybody not? It's fine if you didn't. You didn't? Okay, great. Do you have the book?
No, I'm not supposed to come.
Okay, yeah, you don't need it today. This probably doesn't apply to any of you, but I said that you can use the 8th or 9th edition of the textbook. The 9th is like the current edition. So if you have an electronic copy, it's probably the 9th edition. But the 8th edition is far cheaper. So if you are planning on buying it as a paper book, it's a lot cheaper to get the old one. But I think you all already have the new one anyway, so don't worry about the additions. All right, the final exam, you can see the date on there, Tuesday, May 6th at 8 to 11 a.m. So put that in your calendar. Good morning. Welcome. I hope you can see the screen over there from here. Feel free to move if you can't. Okay, the course content. So this here is just straight from the official course description from the university. It's basically more calculus. So this is a direct continuation of the Calc 1 class. In this class, we are going to be basically doing integrals and sequences and series. So I hope that you have some experience with the integral already. We're going to do more integral stuff and then sequences and series. That's the whole content of this course. Let's talk about mastery-based assessment. It says this is weird, so pay attention. This is weird. I don't know if you have done this kind of grading before. It's a little weird, but I think pretty much everybody likes it, and I think it's a good way to go about things. Anyway, it says this course is graded on topic mastery. The course material has been broken down into about 25 specific objectives to master. And this other sheet that I gave you is a checklist which has all of those things. There are 26 of them on the list. And your job to do well in this class is to master each of the 26 things. And as we go, so you should keep this piece of paper. I'll give you another one if you lose it or something, but ideally you should keep this piece of paper. And every time we take a test, you are going to try to get some of these questions right. And if you get those questions right, you check them off of the list, and that means you're done with that question and you don't have to do it anymore in the future. This is the basic idea. Let's read the words it says. So, students demonstrate their mastery of each objective by correctly answering quiz questions or test questions, each of which is clearly labeled as one specific objective. So every question on we're gonna have quizzes and tests. Every question on every test or quiz will be numbered in this way. So like number 7 will always be about the natural logarithm. And if a student answers a question correctly, this objective will be marked as mastered. So every time you do one of these questions, you can get 0 points if you do it like completely wrong. 3 points is completely right, and some amount of partial credit in between. And then based on how many points you get, you should check them off of your list as you go. If you get 3 points on that question, then you don't have to do that question again on future tests. So the idea is every test includes all the questions. So you get a few tries to get it right. And if you get it wrong the first time, there's no penalty really. Like something that is a little weird is like your grade you don't really have an average that you have to make up. So it's not like if you do bad on one test and then do really good on another test and they average out and your grade is like somewhere in the middle. It's not like that. If you do bad on one test, it doesn't really matter as long as you eventually check the things off of your list before you get to the end. I hope this is making some kind of sense. It's weird, I know. It says, the last paragraph here, there is no penalty if the student answers a question incorrectly, but this objective will remain unmastered. The student can try again to master that objective by correctly answering questions on later exams. So the idea is, right now you have 0 points total. By the end of the semester, hopefully you have checked off everything with 3 points, and then you'll get an A at the end. All right? If you take a test and you still have 0, I would say you should be concerned, but it doesn't ruin your grade, because you could, on the next test, get them all right, and then your grade is fine. There is no sense in which getting it wrong gives you some kind of penalty in your grade, as long as you eventually get it right. And to me, like, this is actually, I want to do the grading this way because I feel like this is more sort of true to how people learn stuff. Like, as far as I'm concerned, I am not, I don't really care if you get it wrong once or twice. What I care about is that you eventually figure it out. Like that, the whole way that you learn is by doing it wrong a few times and then doing it right. So that's how the grading works. You can get it wrong if you want to, and this does not affect your grade, although it does mean that you have to eventually get it right. Like, it's best for you if you get it right the first time, but it's okay if you don't. That's the idea. Any vague questions at this point? I think this will become clearer as we start to do it. That's the basic idea. I hope this sounds like a good system to you. I think it's good. So turn the page and you will see something about quizzes. So the idea is, like I said, we're going to have big tests on WIT, and for all of our tests, you will have an opportunity to do all of these items, at least the ones that we've gotten to so far. But we are also every week going to have a quiz. So each Friday there will be a quiz at the beginning of class, and this is meant to be kind of a brief thing, usually like 1 or 2 questions. We'll take 10 or 15 minutes to do it, and then we'll immediately go on with the rest of class. So not meant to be a super big deal. It says the quiz will be an opportunity for students to earn mastery points on the new items for that week. Each quiz consists of one question from each new topic covered in the previous week. The idea is every week we have a homework assignment that's due on Wednesday, and then right after that, on Friday, we have the quiz, which covers the stuff that was on that homework assignment. And the quiz includes one question per topic from the homework, and if you get that thing right on the quiz, you can check it off with full credit, and by the time that question appears on the test, you don't have to do it because you already got that one right. In fact, we're having these quizzes every week. Every one of these topics will appear on one of these quizzes, and if you are getting them perfectly right every week on the quiz, you don't even have to do the test because you will have already gotten all the things checked off. And by the time you get to the end of the semester, if you got them all right on all the quizzes, then you don't have to do the final exam because you've already gotten all the things checked off. This is the idea, all right? I know people love to skip the exams. You can, if you want. All right. Also, it says once every 2 weeks, students can make an appointment with the professor during office hours to attempt an old mastery question. So this is, you get one shot at it on the quiz, and then you can get further shots on it on our big tests. And I'm saying every 2 weeks you can come to my office and do one more attempt at one of the old ones that you missed on the quiz. All right. So I don't know if this is super confusing, but I think it will become very clear as we go along. It is somewhat confusing for me. It means that as we go along, I have to keep track of every one of your points for every question for all of you. I have a giant spreadsheet with all of these things in it. I will leave it up to you to be, you have to be keeping track of your scores per question, which is, I suppose, a little bit confusing. If you ever lose track or whatever, you can ask me and I'll tell you what I have for you in my books. All right, let's just talk about the homework here. It says the homework is due every Wednesday evening. You're going to submit it online, so it's not due during class. The homework that's what it says, does not need to be submitted during the class meeting. Anytime before midnight on the due date is acceptable. I want to do it that way because, in my experience, if I make the homework due on Wednesday, probably most of you are going to do it on Tuesday. And if you don't really figure stuff out, there's not a lot of time for you to react. So if you should obviously try to do the homework earlier if you can, but if you don't end up doing it until the day before, it's totally fine with me if you are doing the homework, come to class on Wednesday and you still have a few questions about this or that, we can talk about it, and then the homework's not due during class on Wednesday, it's due sometime Wednesday evening. You're going to submit it. Okay, assignments will be posted at the class website, like I said, and the homework will be graded in the traditional way that is not mastery based. So the homework is just like every time you do the homework, I give you a grade, and your homework grade is the average of all of your grades. So for the homeworks, it is true that if you just are skipping homework assignments, you're gonna ruin your homework average grade. This is not the case for the tests, but that is the case for the homeworks. All right, and it says late homework without excuse will lose 1/3 credit for each calendar day. If you got something going on, you have reasons, let me know, we can talk about it, but otherwise that's the deal for the homeworks. All right, the exams, it says, so we're actually not going to have a lot of big tests. There's going to be one in-class midterm exam, which is, you can see there, on March 21st. That's a Friday. And then there'll also be a final exam at the usual final exam time. So this is, the exam is your chance to get the ones right that you missed on the quizzes from week to week. All right. And like I said before, if you already got the question right on the quiz, then you don't have to do it on the exam. All right, I think this is all I need to say about the grading. Any questions about this? I know that this is a weird system. I hope it's not too crazy, and I hope that it sounds like a good idea too. I think it's works well. One thing that I would like to caution you about, it is true, because of the way that this grading works, that your grade, it's a little complicated. If you ask me, what's my grade right now? It's a little hard for me to say that, because right now your grade is 0. you're all getting an F right now, which is not, I mean, that's true, but not very meaningful because of the way the grading works. Another thing that it means is like I said, it is possible for you to just straight up get zeros on all the quizzes, but then by some miracle you can still get an A at the end if you get 100 on the final exam, for instance. And really, it doesn't matter what happened throughout the entire semester. This may give you some kind of false sense of security. If you really are doing terribly on all the quizzes, yes, it is mathematically possible for you to pull it together by the end. But I would say this is, in my experience, unlikely and very difficult. And so I hope that you are not lulled into a false sense of security based on the fact that, people ask me oh, what's the best I could possibly do? And in this class, the answer is always, well, you could finish with 100%. It's unlikely, though, if you've been doing badly all along. So all that is just to caution folks. All right, you can see at the bottom of the of this page here, the grading. So your overall grade is 75% based on this, and then 25% based on the homeworks. So what I just said is not entirely true. If you just, skip all the homeworks, even if you get all of these right, you still won't get an A for the class because there's an average with your homework scores. All right. Anybody got questions? I think I've said enough about this. This hopefully will become clearer as we go week to week. Any thoughts about it? All right, great. So let's talk about the online submission. I am going to have you submit your assignments with something called Gradescope. I don't know if you're familiar with Gradescope, but I would like for us just to take a moment and familiarize ourselves. You should have gotten an email a couple hours ago from Gradescope. Anybody? I see some people say they did. I would like for us all, Gradescope, like this. The way that Gradescope works is it's not really like an online homework system in the traditional sense. You're gonna do all of your work on paper by hand, and then you just take a picture of your page with your phone and then send it into this thing. So I would like for us right now to all try and do this, just to make sure that everybody is able to connect with Gradescope. You should have gotten an email a couple hours ago about your account, and it's best if you do the whole thing on your phone. This is my suggestion, because you need to take pictures of your work on paper. So I saw everybody getting out their computers. You don't need to use your computer. You should use your phone. You can use your computer if you want, but I think it's easier. So use your browser. There is a Gradescope app, which I've never tried to use. You can get that if you want to, but for now, it's perfectly fine to just go to gradescope.com. Use whatever they sent you in the email to help you log in. And then I would so this is just going to be our first assignment. If you log in properly, you should see something called dummy assignment. This is not for credit or anything. I just want to make sure that everybody is able to connect and actually submit something. And the assignment is, tell me something interesting about yourself. You are going to write something on a piece of paper and take a picture of it and send it in. This is how you are meant to interact with Gradescope. And if you don't mind, I'm gonna sort of walk around and make sure everybody is able to work it out. I will try and help out if something is not going right. Once everybody's good with this, we'll get down to some real business. mostly it seems to have worked out okay. It's not essential that we work out all the details right now, but our first homework time will be next Wednesday, so we got to figure it out by then. Let's get down to some business here. There's just a few more things on the syllabus here that I wanted to mention. One thing is just about my office hours. What that says is basically I hope that you will feel comfortable and enthusiastic about coming to see me in my office every so often. Of course, this is not required or anything like that, but it is part of how I see like my job as being the professor for this course, and it is something that I, to be honest, is more sort of enjoyable to me to talk with you, individually rather than just stand here and talk to the whole class at once. If you have questions about the homework or whatever else, I would be happy to chat with you. This is not something that like only people who are doing terribly in the class should come and talk to me. I don't feel that way at all. I feel like everybody from time to time might find it helpful, and that would be great. All right. Oh, I put that on the syllabus twice. This thing about office hours. I didn't mean to do that. There's a little note at the end there about counseling services. Check them out. Free counseling. Can you believe it? This is like the last time in your life that you'll be offered free health care. I have found counseling to be helpful in my own life from time to time. Every so often I'm talking to my wife about something and she says, maybe you should talk to Stacy about that. Yeah, maybe. Stacy has been helpful. Check it out. I don't think Stacy is available at this place, but somebody else who I'm sure is very capable. All right. I think that's all I wanted to say before we get started. I am going to use this screen for everything. I hope that's all right. I know it's a little small, but I hope you can see from where you're sitting, and feel free to move around if you can't. Let me know if there's glare or something. From where I'm standing, there's a lot of glare from the windows, but I think for you guys it's maybe better. The reason I'm doing this is because I am recording every class what happens on the screen. So it's been recording all this time, and then after class every day I'm going to post these recordings on YouTube, and you can see them, go back and like and subscribe, and you can watch them after the fact. I hope this is helpful. This is just so that if you certainly if you miss class someday, you can watch the recording, but I think you might find it helpful just if you're studying before a test or something to go back and look again. So I'm going to, all of this stuff that I write, I'm going to post as a PDF so you can see after the fact, and then I'm also going to post the whole video if you want to. All right, and I think where you can find all of these things on that QR code, the class website. That's where I'm going to post all the things. All right, any thoughts about any of that? Great. I think I'm ready to talk about some calculus then. So our class, I get the time straight. I think we go till 10:45, right? Yes. All right. Great. So, like I said, the topics for this class is basically the integral and then sequences and series. And I hope that you have some familiarity with the integral already. Probably you haven't done anything with sequence and series, and that's to be expected. That's fine. So today I want to do what might be just like a little bit of review. And you can see if you look at the checklist here, the first two topics are what I consider to be review topics, and I want to do maybe all of both of those today. Simple derivatives and antiderivatives. This is just total review stuff, and then the u-substitution, which is something that I hope that you're all familiar with. It is, I hope that you've already done it before, but it's going to be fairly important for this class, so I just want to make sure everybody is feeling good about it. So let's talk about those. I think one thing I forgot to say about the list, I wrote this at the bottom. Bring this list to your exams and don't write other stuff on it. So just because when you get to the test, You're going to have certain of these questions you've already got full credit on, and you don't have to do them on the test. And so you can bring the list with you just so that you know which ones you want to focus on the tests. All right, enough about the list. Okay, so let's talk about simple derivatives and integrals. That's the first thing on the list. All right, we are going to use the derivative every so often in this class, although most of our topics are about the integral, the antiderivative, but the derivative, of course, comes up fairly often. So the most important rule about the derivative is this one. The derivative of x to the n is n x to the n minus 1. This is called the power rule, and if you know anything about the derivative, this you use all the time when you're doing typical calculus type questions. And there is a similar rule for the integral, the antiderivative power rule. The integral of x to the n is kind of the opposite. So the derivative rule is you take the exponent multiplies into the coefficient, and then you decrease the exponent by 1. The integral rule is kind of the opposite, which is to say, instead of decreasing the exponent by 1, you increase the exponent by 1. And then instead of multiplying into the coefficient, you divide into the coefficient like that. So there are various ways you could write this formula, and I don't really care how you want to write it. Some people write it as one big fraction, x to the n plus 1 over n plus 1, which is fine. As long as what you're doing is correct, that's fine with me. And by the way, this is basically, this is a general principle. Like if you took your Calc 1 class, from somebody else, probably the way that I write things or the way that I talk about things might be slightly different from the way that you've learned it in the past. And if you want to do it however you learned it, it's totally fine with me, as long as what you're doing is actually correct. It's fine if you like to write things in a different way than I do. All right. Okay, those are the very basic derivative and integral formulas, the power rule. So for example, if I want to say like the derivative of x to the 4, somebody want to say? Shout it out. Yes?
4x to the third.
4x to the third. Excellent. Yeah. Or something like, this is a little fancier, derivative of 8 root x. What is that? Anybody recall how do you handle the root x? Somebody else maybe? Yeah?
X to the 1/2.
Yeah, root x is the same as x to the 1/2. So this right here, I think of as x to the 1/2. And then you do the same rule, which is to say the 1/2 comes down into the front and multiplies with the 8, and I get 4 in the front. And then x, it used to be 1/2 in the exponent, but I have to subtract 1. So I go 1/2 minus 1, which is negative 1/2. So it's like that. This is the derivative of 8 root x. It is 4x to the minus 1/2. Right? Great. I said before, you can write your answer however you like. Some people like to write this instead as 4 divided by the square root of x, which is the same as that, although in my opinion, a little strange. Here's something you should not write. Don't do this. How about derivative of 8 root x? This is 8x to the 1/2, and this is 4x to the minus 1/2. I don't like that, actually. Anybody see the problem with this? Yeah? Yeah, right. She said this d over dx really ought to be here also, because in that step I didn't do the derivative. All I did was I changed this to that. These two things as written are not actually equal. That really what it should say instead is that, right? And then I have no problem. Now it's actually true. Whatever. Don't write it like I did before. Okay, how about the integral version of this? If I have something like 3x to the 5 plus 4 dx, what's the integral of that? You do the power rule, but the other one for the integral, the other one is you increase the power by 1, and then you divide by the new power. So that 3 will sort of stay like it is as a coefficient, but then x to the 5 becomes 1/6 x to the 6 plus the 4. Anybody remember? I didn't actually say this before, but what's the antiderivative of just the constant 4, the integral of that? Anyone remember how to handle that? Yeah?
It would just be C.
C. There is going to be a plus C at the end.
Oh,
but there's
that would be X, right?
yes, I think. So what should I put here instead of 4?
You put X.
I would put, that's close. We want to help out? Yeah?
X.
That is kind of close also.
Oh,
4x. Yeah, if you have just a constant, it becomes that same constant times x. So it is 4x. Yeah. That's because remember what you're doing with the antiderivative is it should be something like the opposite of the derivative. So if you had 4x and took the derivative, you would get 4. And that's why if you start with 4 and do the antiderivative, you get 4x. All right. I hope that these things, will come back to you as we go. Okay. These are all how to handle polynomials. You should also know how to handle trig functions, sines and cosines. And there are probably like several obscure formulas that you learned from time to time. Really for our purposes, and at least to start off with, all that I really care about is that the derivative of sine x is cosine and the derivative of cosine is negative sine x. All right, these are the very basic derivative formulas for the trig functions. You definitely need to know those two. There's one for the tangent and the other weird trig functions which don't come up so often, although they will come up eventually, but for now, as far as review goes, these are the ones I care about. And then, along with those, we have similar integral formulas. And this is a little confusing. You just have to remember the way it goes. The derivative of sine is cosine. The antiderivative of cosine is sine, plus c, of course. And then the derivative of cosine is negative sine. The integral of sine is negative cosine. And you just have to sort of remember when it is appropriate to use the negatives. You got to keep it straight. All right? Other things that I will expect you to know, but don't actually come up all that often in this class, are things like the product rule, the quotient rule, the chain rule, those things. I will expect you to know how to do that stuff, but that's not really what we're going to focus on in this class. All right, any questions about this so far? I hope, by the way, that you will feel free to interrupt with questions if you've got them. Okay, how about these, what we've been doing so far, these integral signs? This is technically called the indefinite integral. That is an integral sign where the answer is another function. You start with a function and you get another function. There's also something called the definite integral, which represents the area under the curve of the function. And that's the one which has the two little numbers on it. So just to make sure everybody's clear on that, here's the one with the two little numbers. This is called the definite integral. The integral from 3 to 8 of that function right there. And I hope everybody remembers how to handle that. First of all, you do the antiderivative of the function part. So x squared becomes 1/3 x cubed. Negative 7x becomes minus 7 over 2x squared. You increase the power by 1. That x is like an x to the 1, and so I increase the power, becomes x to the 2, and then I got to divide by 2. And then the plus 2, just like before, becomes plus 2x. A constant by itself becomes that same constant times x. And now the difference, the way that we handle one with these little numbers here is, instead of putting the plus c at this point, so this is the way that I I'm always going to write these. I put the bar and the 3 and the 8. And the bar, for some reason, I don't know, I didn't make this up, the bar always goes on the right side of the stuff. The integral sign goes on the left side. And then what the bar means is, it means I'm going to plug in 8 to this function and then subtract and then plug in 3 to this function. So my answer shall be 1/3 8 cubed minus 7/2 times 8 squared plus 2 times 8. So that was going through the whole thing, plugging in 8 everywhere, and then I go subtract. You better put parentheses here, or else you won't properly distribute the signs. And now I go through again and plug in 3 for x everywhere. So it's 1/3 times 3 cubed minus 7/2 times 3 squared plus 2 times 3. And this is my answer. All right. Now you could, I don't know about your upbringing. A lot of high school students are trained to like become some kind of simplifying machines. In my opinion, this is the answer, and I'm going to leave it at that. If you really want to, you can simplify all of this. You can type it into your calculator if you want to. I don't care about any of that. In my, like, this class here is about calculus, all right? So if I ask you to do an integral, you should do the integral, get some kind of numbers, and leave it at that. This class is not about, do you know how to like multiply fractions together or whatever. If you want to multiply the fractions together, that's fine, and I hope that you do know how to simplify this if you really had to, but I don't care about any of that. Yeah?
Can you explain how you got 7/2?
Yeah, sure. 7/2 here, right? It used to be 7 times x. This x, you consider that to be x to the power 1, right? And then the rule is I increase the power by 1, so this 1 becomes a 2 here. And then you also have to divide by the new exponent. And that's why there's a 2 on the bottom here. So this, if you prefer, you could write this as 7 times 1/2 x squared, which is the same as 7/2 x squared. Yeah, great. All right, so when you're doing like homeworks or quizzes or tests or whatever, I will expect you to just leave your answer like that. If you start trying to simplify, you'll probably screw it up, and I don't care anyway. All right, excellent. Oh, let's just try one other. So one other thing that I hope that everybody remembers, how about this? The integral from pi/3 to pi/2 of sine x dx. All right, first of all, we have to do the antiderivative of sine x, which is, anybody recall? I just wrote it a few moments ago. What should the antiderivative be? Yeah?
Negative cosine.
Negative cosine, yeah. From sine, you always get cosine. You have to remember the plus or minus. When it's the derivative of sine is positive cosine. The integral of sine is negative cosine. All right, and I got to plug in. And these, I will expect you to know how to evaluate these. So this will say negative cosine pi/2 minus negative cosine pi/3. And on a typical question like this, this question exactly is probably too easy to put on the test or something, but I would say something like simplify all the trig functions in your answer. So I will expect you to know how to do these. Hopefully you have some kind of remembered like chart of various values of sines and cosines on the unit circle, or maybe you remember certain shapes of basic triangles. I hope that you still remember all of that business because it is going to be important. And I hope that you are able to make sense of these angles. These are radians, of course. You can convert them to degrees if you like, or just know what these angles represent. Pi/2 is the same as 90 degrees, and pi/3 is the same as 60 degrees. Anyway, anybody actually remember the cosine of pi/2? This is like any of that? Yes, it's 0. Yeah, I have to think about it too. So the way that I remember cosine of pi/2, the shape of cosine is, you can remember this however you like, but this is the shape of cosine, right? Where that's pi/2, and this is 3pi/2, and this is 2pi. Anyway, cosine of pi/2 is 0, so this is 0, and then minus negative. Cosine of pi/3, pi/3 is 60 degrees. You can just, some people just have sort of some kind of chart of the unit circle memorized. If somebody asks me on the street what is cosine of pi/3, I think of the 30, 60, 90 triangle. This is pi/3 here. And the sides of such a triangle, I hope you remember something like this, go like that. One root 3 and 2. This is how I remember cosine of pi over 3. And then I do the cosine is the adjacent over the hypotenuse, which in this case is 1 over 2. So that is like that. And you could leave your answer like this, I suppose, although the whole thing is just a half, right? So I hope that you know, if you haven't done trigonometry in a while, you might have to review some stuff about this, but I hope that this is at least something that you can remember, that you used to know that, and look it up. All right. Excellent. This, I got something for you all to try, if you don't mind. How about... I got 3 of increasing difficulty, maybe. No, I got 4. The first one you can do sort of as is. The other ones you will want to rewrite a little bit in order to do the integrals. Sorry, I left out some dx's. So what I like to do, you know, from at least, you know, once every class meeting, I like to give you some for you to try, and I'm gonna walk around and see how you're doing. I'm not trying to like give you a grade or anything like that. I just want to make sure that everybody is following along, and you know, feel free to. You don't have to talk to me if you don't want to, but if you've got questions, I am eager to assist. Also, feel free to chat with your friends about it if you like. If you've got any, you can try them together. let's take another couple moments and then we'll talk about them. All right, can we talk about these? I know not everybody is finished. That last one is a little tricky. The first two, as I was walking around, pretty much everybody ended up getting these. Just a technicality, this one ought to have a plus C on it. This one should not. When you do the definite integral with the numbers, the answer is just a number. When you do the indefinite, that's the one without the numbers, the answer is a function with a plus C at the end. So there should be, I'm not going to go crazy about on the grades, of course. If you forget the plus C, usually it doesn't really matter, although sometimes it does matter, and technically it should be there. Okay, these ones. This one here, this is a little technicality, but I hope that everybody realized, when you have x to the 6 on the bottom, you should turn that into x to the negative 6. This 3 on the bottom needs to stay as a 1/3. You should not write, so this needs to say 1/3 x to the minus 6. It should not say 3x to the minus 6. Some people brought the 3 up also, but the 3, you sort of bring this x up and you compensate for that by making the power negative. You can't just straight up bring the 3 up and leave it as a 3, because 3 in the bottom is different from 3 up top. Anyway, it should stay as 1/3. But then I continue, so this will say 1/3, and then I do the thing with the exponents in the next thing. So negative 6, I increase by 1, it becomes negative 5. So this will be 1 over negative 5, x to the negative 5 plus c, and that's it. You can multiply those coefficients if you want, 1 over negative 15, or just leave it like that, I don't care. All right, any questions about that one? That one is not so tricky, you just have to make sure you leave the 3 as a 1/3. Okay, and this one is maybe the most complicated of the ones. You have to simplify this quite a bit before trying to do the integral. So first of all, when you have a fraction like this, you cannot just do the integral in each part here. So you can't say this is like 1/3 x cubed here, 7x here, and 1/3 x cubed down here. You can't do the integral inside of a fraction like that. So you have to somehow rearrange this thing. There are a few different ways to do it, but I think the most straightforward approach would be to write it like this instead. So instead of dividing by x squared, I write it as times x to the minus 2, and then I'm going to distribute that multiplication times x to the minus 2 distributes, like so, right? And I'm not doing the integral yet, so I'm going to write the integral sign again. X squared times x to the negative 2 is 1, right? You could say adding the exponents, you get x to the 0, but that's 1. So this is 1, and then minus 7 times x to the minus 2. That is distributing x to the minus 2 onto each of those two things. And now this thing just looks like an ordinary polynomial on the inside, and so we can do the antiderivative of each of those two parts. From the 1, I get 1x, and from that other thing, I get 7 over negative 1x to the negative 1. And then I put the bar. All right. It was a negative 2 power. I increased that to a negative 1 power, and then divide by negative 1 in the coefficient. Everybody feeling good about that so far? Not quite done, but that was the hard step. All right, and then we just plug in the 3 and the 1. So my final answer then is 3 minus 7 over negative 1 times 3 to the negative 1, and then subtract 1. 1 minus 7 over negative 1. 1 to the minus 1. This I'm sure you could simplify if you wanted to, but I don't care about that. Anybody got questions about that one? A little bit strange. This is how we do it though. All right. So this is the kind of stuff that you should expect to see on the first topic on our big list. This is called simple derivatives and antiderivatives. This one I'm not sure I would describe it as simple per se, but at least it doesn't actually involve any fancy tricks, which we're going to learn, later on in the course. Fancier tricks for doing fancier types of integrals. This one is just simple tricks like distributing and whatever. All right. Any questions about any of those? All right. Great. We have about 20 minutes left. I think that's enough time to start talking about the u-substitution, which is the first sort of non-simple trick that we are going to talk about. Although this, like I said, I hope that you are all familiar with this already. The u-substitution, all right? This is an integral trick. It's a trick for doing integrals, which is based on the chain rule. This is a trick based on the chain rule. And the idea is you look at an integral and you change the variable to make it look, to make the integral look easier. So the idea is you change the variable to simplify the integral. And for example, if you have something that looks like integral of, let's say, 5x plus 2 to the power 6 dx, all right? This is complicated because of the parentheses and the 6. If it was just 5x to the 6, then it would be totally fine. But because it's 5x plus 2 on the inside of the parentheses to the power 6, then this is complicated. But your idea when you look at that, you should somehow think like all this is really is a power 6 with some other stuff, right? This is really the same as just sort of some stuff to the 6th, right? And if it was just something to the 6th, then we already know how to do that. Then you would just do like 1/7 something to the 7th, right? So it's really the same as some stuff to the 6th. And so the idea that the way that we actually write this out, formally speaking, is you say something like, you let u equal 5x plus 2. That's why this is called the u-substitution, because typically, I don't know why people use the letter u when they do this trick. You say let u equal 5x plus 2, and then this integral of 5x plus 2 to the power 6. This is hard because of the weird parentheses and all that. This just turns into integral of u to the 6, which is easy, right? The integral of that is 1/7 u to the 7. This is the sort of the spirit behind the u-substitution. This is why people do the u-substitution. It is to transform a hard integral into an easier integral by changing the name of the variable. Now, those two things that I wrote here, actually, technically, this is not equal to that. There is a little technicality that you have to deal with, and that is, I didn't write it here, but this, there should be a dx there. There should be a I guess a du here. And the entire sort of details of the technicality involve how to change dx's and du's. So these are slightly complicated, although it's not really all that complicated, but we need to work a bit, I mean a very small bit, to convert dx to du. And they are not just straight up equal, so you have to do a little bit of, a little slight bit of funny business to sort of change the dx into the du, although it's really not such a big deal. But anyway, the upshot is, since we've all seen this before, I hope, the du is the derivative of the dx. All right. So while you're doing this problem, the overall problem is about doing an integral. You actually have to do a derivative as one of the intermediate steps. All right. Anyway, let's just try a standard example of a u-substitution. Actually, we could try and do that one that I just wrote there. Integral of 5x plus 2 to the 6th dx. All right. Let's try this one. So we begin by choosing what the u should be. And like I said before, I'm going to pick u equals 5x plus 2. And this is sometimes this is the hardest part. You just have to be able to look at this and figure out what should I choose to be the u. And there are not any like hard and fast rules about this. There are kind of general principles, which I will try and say in a bit. But the most basic of the general principles is if you see like a thing inside of another thing, something inside of parentheses or something inside of square root sign or something like that, generally the inside part is what you want to choose to be the u. So that's why I picked just the inside, not including the power 6, to be my u. Okay, and then what I said up here, du is the derivative of dx. So that's not true. I meant to say the derivative of u. Can you scribble that out? Sorry about that. They're going to give me bad comments on the YouTube. It's the derivative of u. That's why it's called du. Du is the derivative of u. So in this example right here, we can immediately say what the du is. The derivative of the u. U is 5x plus 2. What's the derivative of that? Can somebody say? 5, yeah. And this is a little technicality. It always includes a dx. So here, in this example, it's not such a big deal. Most of the examples you've done, probably it doesn't matter that much. Like sometimes people forget to put the dx there. Actually, it is going to matter when we do this later on in the course. You really want to remember this dx. So du is, I will just say it again, the derivative of u and always times dx. The du includes a dx in it. All right. And then there's one sort of little step that I'm going to do, and this is a step that some people do slightly differently. You might have learned to do this a little bit differently, but what I'm going to do here, I call this dividing the constant. I have du is 5 times dx, but I don't like the 5 on this side. I like it over here instead. So I'm going to divide both sides of this by 5 and write this instead as 1/5 du equals dx. All right. The reason I do that is because it makes it very clear how I am going to translate the various parts of the integral. So this integral on the left, it equals, first of all, 5x plus 2 in here equals u. So I can just say this is u to the 6. And then times dx, which I said down there is 1/5 du, all right? So this is why it's called u-substitution. Really, it's all about just substituting. Here, instead of 5x plus 2, I write as u, that's the substitution. And then instead of dx, I write 1/5 du, because that's what dx is, like so. All right, now we have simplified the thing inside of the integral, and so we can just do the antiderivative. I'm going to do one last sort of preliminary step. This is another basic fact about the integral. If you have a constant multiple inside, you can pull that all the way outside of the integral sign. I hope that you all remember that. So this is the same as 1/5 integral u to the 6 du. And now we can just do the integral like we always do. U to the 6 becomes 1/7 u to the 7. So this is, I still have a 1/5 outside, but then 1/7 u to the 7, and now I put my plus c. That's the step at which we actually did the integral, did the antiderivative. All right, and this is basically the answer, although since my original question was in terms of x, right? This was about the antiderivative of some function of x. You should really write your answer in terms of the original variable, and this is always easy to do. It's just a matter of sort of undoing the substitution or resubstituting. Instead of u, I'm putting 5x plus 2. So this is my true and final answer. 1/5, 1/7, and then 5x plus 2 to the power of 7 plus c. That's how we do the u substitution. All right. Anybody got questions about that one? This, I don't know if this looks complicated. Unfortunately, that's an easy one. This is kind of the easiest type of u substitution that you might see. We are going to do much more complicated ones as we go throughout the class. This is the basic idea. All right, I got a couple more, and then we're just about out of time. Let's do 2 more. I don't think we have time for you all to try some, but we'll get that next time. In the nursing building tomorrow. Okay, here's another one. All right. This one immediately looks a bit more complicated because it has this thing inside the parentheses, but then it also has that 2x there multiplied by that. One thing that you hopefully remember is, like, you really don't want to see multiplication inside of an integral sign. If you're doing the derivative and there's multiplication, you can use the product rule. But if you're doing the integral, there is no such thing as like a product kind of a thing for the integral. And so it means you have to do some fancier trick. And as of now, the only fancier trick we know is the u substitution. But anyway, I'm going to kind of ignore that for now. I am going to choose the u to be something on the inside of something. Anybody want to suggest? What should I take for the u? Yeah? X squared plus 10, she says. I like it. Okay? Choose the inside of something is generally the way to go if you are doing a u substitution. Next, I find the du. Anybody want to say what should the du be? It is always, yeah? 2x. And I think I heard her say, maybe she said deep down in her heart, dx. Remember, the du always includes dx at the end of it. So 2x dx. Du is the derivative of u. So it was x squared plus 10. The derivative of that is 2x. Excellent. And then I am going to, again, I think, you know, when I was going to say I should divide this constant over to the other side, although in this case I don't think it's really necessary. Dividing the constant if you want to. Anyway, I have to do the various simplifications. Now, this one, I meant to say substitutions. I'm going to try to rewrite all of this stuff using u's and du's instead of x's and dx's. And in this case, it's slightly complicated, but I would like to, and maybe if you know what you're doing, you can do all of this in one step in your head, but just for the sake of being clear about everything, I'm going to, first of all, put the u where it goes. Like the u is x squared plus 10, which is this part. So I'm going to, this is sort of an intermediate step, but this is 2x times u to the 6 times dx, right? I just put the u in. And now I have what's left. Ideally, I want everything to be u's and no x's, right? Here, it's kind of somewhat jumbled up at this point. I have some u part and then some x's part. Just to get it straight in my mind, I like to sort of gather the u's together, kind of on one side. I like to put the u's on the left and the x's on the right. These are all multiplications, right? So you can rearrange the order however you like inside of the integral sign there because they're all multiplied. U to the 6 and then 2x dx. And the what I'm trying to do here is, what am I supposed to do with 2x dx? And by some sort of magic, it straight up equals this, which is du. So I sort of got lucky in this case that this part, which was left over, is actually equal to the du part. So this is just equal to u to the 6 times du. And now the substitution is complete. I'm not totally done with this problem, but this is the end, at least, of the substitution. Now everything is in terms of u, so we can actually do the integral. This, just like last time, becomes 1/7 u to the 7. Here I put the plus c because I just did the integral in that step. And then the last step, as always, is to replace the variable with x's. So instead of u there, I'm going to plug back in x squared plus 10. So I get 1/7 x squared plus 10 to the 7, and then plus c. There you go. All right. Do we have time for one more? We got 3 minutes. I think we can do one more. It's going to be great. One more. This one's got a square root sign in it. Don't worry about it though. All right? We are, again, going to do the u substitution. And on the general theme of choose something on the inside of something, anybody want to suggest what should I pick for the u? Yeah?
1 minus x cubed.
1 minus x cubed. Yeah, pick the inside of something or other. In the previous examples, it was inside of parentheses. Here, the only sensible thing to choose for the inside of something would be 1 minus x cubed. Don't also take the square root as part of the u, just the inside. All right? Then the du is the derivative of that, which will be 3x squared dx. Negative 3x squared dx. All right. And now, maybe if you have some idea of how these things generally go, look at this part here and see if the parts are actually going to match up with what we have over here. I have this part, so the square root part is just going to end up saying root of u, right? Because that's going to be the u. What's left over is x squared and also dx, but I kind of feel good about that because I see x squared and dx right here, all right? The only sort of oddball is this negative 3, but I can divide the constant across. So here, just like we did 2 times ago, I can divide that 3, and it looks like this now. And now I'm feeling very good about the way that this substitution is going to go. This part here turns into u, and then the rest of it is x squared and dx, but that's this. And so that will turn into 1/3 du. So the way I would write out the steps would be sort of, the first thing that happens is I put u right there. And then what's left over, apart from the u, is x squared and dx. And if you want to really sort of clarify that, you could rearrange it in this way. Like I said before, if you know what you're doing, you don't have to write these intermediate steps, and it's fine with me if you want to do some of these in your head. That's totally fine. And then x squared dx is negative 1/3 du. So I go root u and then times 1 over minus 3 du. That's because of this. X squared dx is 1 over minus 3 du. And then one last step before I do the integral. Sorry, I'm going to rush to the end because we have to go in a minute. This is, you can pull a constant out of the integral sign. Now the integral is sort of fully simplified. We didn't do the integral yet, but this is as simple as it's going to get. How do we handle the square root of u? We should write that as u to the 1/2. So this is negative 1/3 integral u to the 1/2 du. And now I do this integral. u to the 1/2. We increase the power by 1, so the power is 1/2. I add 1 to that, it becomes 3/2. U to the 3/2, and then in front I go 1 over 3/2. You could write that as 2/3 if you like, being the reciprocal of 3/2, however you want to handle that. And then at this point I put the plus c, because I just did the integral. And then the very last step is put the x's back in. I scrolled them, but the x's are 1 minus x cubed, right? So my final answer is -1/3, 1 over 3/2, and then 1 minus x cubed to the 3/2 plus c. That's it. All right, I think that'll do for today. If you were not able to get the Gradescope to work, maybe try it again some more if you have some time. And if it really is not working, then let me know and we will work something out before next week. All right, great to meet you all. I will see you tomorrow at 9 o'clock over there in the other building.